Okay, we're going to talk a little bit here about the PreLab and the PostLab calculations that you have to do for the empirical formula for silver oxide lab. These are slightly more complicated than the questions for the last lab that we did, but they're not too bad. And I think you guys should be able to figure this out. So, let's see. First one here, it says a piece of iron on the PreLab questions. It says a piece of iron weighing 85.65 grams was burned in the air. The mass of the iron oxide produces 118.37 grams. Okay, so we've got a piece of iron. We're burning it in air, which I know sounds a little bit weird. Unless you've ever seen steel wool when you touch a 9-volt battery to it, you've definitely seen iron burn then, because steel is primarily an alloy made of iron. And iron will burn. It reacts with the oxygen in the air to make iron oxide. Okay. Now what we want to figure out is what is the formula for that iron oxide, because iron can form a couple of different charges when it combines with the oxygen. Okay. And so we don't know if this is going to be Fe2O3, FeO, or what it's going to be. So we're going to do this. It says use the molar mass of the iron to convert the mass of the iron used to moles. Okay, fairly straightforward. So the molar mass of the iron here, well, first of all, the iron was 85.65 grams to begin with. Okay, so we're just going to take 85, that's really thick, 0.65 grams. I better do this on a different screen because that's not going to be able to fit all of that. So let me open up a notebook screen here. That's not it, sorry. So basically we're just going to do a little stoichiometry here. Sorry. Should have had this ready. So these videos are longer than they need to be. I think I've said that in one of the videos before. I need to stop repeating myself. Okay. Now we should be good to go. So let's go back to... So we've got 85.65 grams of the iron that we're initially starting with here. Alright, so 85.65 grams of iron. And all they want to know is how many moles of iron do we have here. That's all this question is asking. So it should be fairly straightforward. In 1 mole of Fe, there are, I think, 55.845 grams of Fe. Okay, so if we calculate that, we're going to get about 1.53 moles of Fe. Okay, so that's how many moles of Fe that we have here. And then the next question is asking us, according to the law of conservation of mass, what is the mass of oxygen that reacted with the iron? Okay, well, we know that iron oxide is the only thing that got produced here. Okay, we started with iron, so if it started out at 85.65 grams and ended up at 118.37, then all we have to do is subtract those two numbers, and that should tell us the mass of the oxygen. Okay, simple enough. So we take 118.37 minus the 85.65, and that's going to give us 32.72 grams of the oxygen. Okay, now they want to know the number of moles for number 3 here, number of moles of oxygen in the product. Okay, so we've got 32.72 grams. So now all we have to do is use the molar mass of the oxygen, figure out how many moles that is. And it's going to be right at 2.045. Okay. And then they're basically asking us an empirical formula question here. Use the ratio between the number of moles of iron and the number of moles of oxygen to calculate the empirical formula of the iron oxide. Alright, so all we have to do here is go back, divide by the smallest of the two, which is going to be the 1.53. and that should give us our numbers. So that's 1. We take the 2.045 divided by 1.53. It's going to give us about 1.33. Okay, and that should be fairly straightforward. Then we need to multiply till whole, so we're going to times both of them by 3, and that's going to give us a 3 to 4 ratio. Okay, which means that the empirical formula here is Fe3O4. Well, that's probably going to seem a little bit weird because that's, how do we get that combination using the charges on the iron and the oxygen? Well, actually, this is called magnetite, this form of iron oxide. And the way it actually forms, you've got FeO with Fe2O3. Okay, so it's kind of a combination of the two that are joined together. So it's kind of a special form of iron oxide. So Fe3O4 actually is the correct answer on this one. Okay. All right. So there's the pre-lab. Now once we get to the post-lab, let me scroll down here. That's going to keep my stuff. I'm going to erase this. Okay. Just about the lab itself. I mean, essentially what we're doing here is kind of the opposite of what we just did in the pre-lab. We're starting with a silver oxide compound, which is black when it starts out. It's like a black powder. And we're going to heat it up and actually decompose it, as opposed to in the pre-lab, the iron is reacting with oxygen. It's a combination reaction, and it's forming iron oxide. So we're kind of doing the exact opposite here, but it's the same basic process that we're using. And so we're going to heat up without the lids on the crucibles because they just fall and break anyway. Basically, you're just heating it very gently at first, and then you're heating it a little bit stronger, and you're going to start to see a change in this thing, okay? And as the silver oxide decomposes, obviously the oxygen is going to go off into the air, and you're going to be left with pure silver. Okay, and so the appearance is very much going to change, and you're going to notice that it's a very silvery-looking compound element, I guess, because it is silver. And then what you're going to do is you're going to measure the mass of the silver oxide before you start. Then you're going to measure the mass of the silver when you're done. And that's going to tell you the amount of oxygen that there was. And so then you should be able to figure out the silver to oxygen ratio in the silver oxide, and then you should be able to figure out the formula just like we did on the pre-lab. Okay, so you're going to record all these things. Now we're probably only going to have time for 2 trials here, and by probably I mean almost definitely 2 trials. So we'll do 2, and what that means is you're going to have to do this calculation twice. Okay, just to double check yourself, and I think the lab sort of leads you through exactly how to do that. I need to stop circling stuff on here, so then I have to erase it. Okay, so the post-lab says create a data results table for each trial, and then it tells you what categories to put in there. So you need to make sure that you do this, okay? You're going to have an extra table this time. The mass of silver oxide in grams, the mass of the silver metal produced in grams, mass of oxygen gas produced in grams, percent composition of the silver, percent composition of the oxygen, the moles of oxygen, moles of silver, mole ratio, and the empirical formula. Okay, all of those things need to be in there. And this is not, these calculations, you're not going to find them too difficult, I don't think. So number 1 here, it's saying calculate the mass of the silver oxide and the mass of the silver metal product. Use the law of conservation of mass to calculate the mass of the oxygen produced with silver. Okay, so let's say for the first trial you get, let's see here. Well, okay, so first of all, to calculate the mass of the silver oxide is not difficult because you're just going to come back up to your table here. And all you have to do is just a subtraction, right? Because you've got you measure the mass of the crucible and the lid, and then you measure the mass of the crucible, lid, and the silver oxide, okay? That's going to give you the mass of the silver oxide. And then the other thing that it tells you to calculate there is the mass of the silver metal. So again, all you have to do for that, take the mass of the crucible, lid, and the silver metal minus the mass of the crucible and the lid, except it's just going to be the crucible, you're not using the lid, okay? So that calculation, it's not really a calculation, it's just a subtraction. I mean, I guess it is, but it's a very easy one. Okay, and then the next question down here, they ask you, what is the percent composition of the, let me erase this here, the percent composition of the silver and the oxygen in the silver oxide. Okay, so what you know at this point, you know the overall mass of the silver oxide, okay, and you know the mass of the silver. And because of those two things, you also know the mass of the oxygen, right? If you take the silver oxide and you subtract the silver from it, that's going to give you the mass of the oxygen. Alright, so you have the mass of everything there. So percent composition, remember, all you have to do for percent composition, I'm going to go over here. Just equals the mass of whatever you're looking for. So let's say we do the Ag first. Mass of the Ag divided by the mass of the compound times 100. Okay? Excuse me. So then you're just going to divide that, the mass of the Ag divided by the mass of the silver oxide times by 100, that gives you your percent. Do the same thing for the oxygen, okay? Again, very easy stuff. Use the molar masses of the silver and oxygen to calculate the number of moles of each product. Okay. So again, very easy. I mean, it's just like what we did on the PreLab. You just take the mass of the silver, calculate the number of moles of silver, and the mass of the oxygen, calculate the number of moles of oxygen. And then calculate the ratio between the two. So again, very, very similar to what we did in the PreLab. Now, the difference here is going to be that your results will probably not be as nice and neat as they were in the PreLab. So you may not get exact numbers. We'll see how close you get, okay? But the idea is, normally, if you're doing an empirical formula calculation, and you're doing it, you know, from a book where they're giving you nice, neat numbers, if you get a ratio like 1.33 to 1, you're going to multiply both of those by 3 till it gets to a whole number. Well, let's say you get like a 1.92 for the moles of the silver, and then a 1 for the moles of the oxygen, okay? Just hypothetical here. Now, that's actually pretty close if you do that. I wouldn't worry about multiplying by some number that makes these both whole numbers. I would say, okay, 1.92, and this is why you're doing a couple trials. So say in both your trials, you're right around a 2-to-1 ratio, then that'll tell you, okay, it's probably a 2-to-1 ratio. All right, if you, in both of your trials, get close to a 4-to-1 or 4-to-3 ratio, then that'll tell you, okay, it's probably that ratio. So again, it's not going to be as exact as it was on the PreLab, but hopefully you can get close, okay? Now, once you do that, you need to write a balanced chemical equation for the decomposition of silver oxide, okay? So I'm not going to show you exactly how to do that because I want you to figure this out, but what you're going to have here, you're going to have your silver oxide, whatever you decide that it is after you determine the empirical formula on the step before. Okay, and that's going to break down, obviously, into Ag plus O2, right? And then you just have to balance this thing, okay? So that's what you're going to do there. And then the theoretical yield of a product is the maximum mass of product that can be obtained, assuming 100% conversion. We want to know the theoretical yield of the silver metal in this experiment, okay? Now, what you're going to do here on number 6, because you have figured out what the silver oxide is, whatever it is, if it's Ag2O, if it's Ag, you might actually have an idea of what you think this is, but let's say, just like in the PreLab, it's Ag3O4, okay? That's not what it is, but let's say. What you're going to do here, you know how many grams of this you had to begin with. It was around 0.5. It should have been around 0.5. So let's say that you had 0.50 grams of the Ag3O4, okay? Then what you're going to do in order to figure out how much silver you should have been able to make, you just do a little stoichiometry here. All right, so grams of Ag3O4, change that to moles, okay? And then using the equation that you just wrote up here and the coefficients in your equation. Now again, it may not be right, but you're going to use your equation, okay? Then you're going to do moles of Ag3O4, compare that to the moles of just the silver, okay? And whatever that ratio is based on your balanced chemical equation that's right here, that's what you're going to use in this step, okay? Then you just go back to grams of Ag using the molar mass of Ag, and that will tell you your theoretical yield, how much you should have been able to make, okay? Then the percent yield is going to reflect the actual amount. Erase this. Alright, so the percent yield, again, they're giving you the formula right there, actual mass divided by theoretical mass times 100. You just figured out the theoretical in step 6, so whatever you figure out here goes down here on the theoretical. The actual mass of the product, that's your average mass of silver that you got in your trials, okay? And so you can take that divided by the theoretical mass times 100, okay? And that's going to give you your percent yield. And then they want you to discuss sources of error in the experiment. It might account for percent yield both lower or higher. You have to answer both of those questions, okay? And it is possible to get on your calculation to get a percent yield of higher than 100, okay? And there's one main way that you could do that. You can probably figure it out on your own. I'm not going to tell you, okay? So I want you to think about this question, especially number 8. They like to ask these sorts of questions on the AP exam, these lab analysis questions, these source of error type questions, okay? So don't just skip over that. Don't, skirt your way through that. I want you to actually think about it, okay? All right. So that's it for that lab. Hopefully that makes sense. Again, not too difficult on the calculations. I think you guys should be fine. All right. See you next time.